Welcome to the Cynical Developer Live. This is the podcast that helps you improve your development knowledge and career through explaining the latest and greatest in development technology, providing you with what you need to succeed as a developer. This is the second part to the episode about prosthetics with .NET with Clifford Agius. If you haven't listened to episode 137, I suggest you go back and listen to that episode first so that you can understand what's going on. But without further ado, here's the rest of the episode. Oh, it's amazing. Absolutely amazing. So we talked about 3D printing it. We talked a little bit about the 3D design side of it. But one thing you did touch on as well is the fact that unlike the older NHS versions that are mechanical, this is software driven.
It is.
Which, yes, that's still mechanical in some sort of way, but you know what I mean.
Yeah.
What sort of software do you use to actually run that?
Yeah, well, the Open Bionics one, originally, they had designed their own board called a chestnut board, which sat in the back of the hand and had all the motor drivers, drove these little actuonic motors that are basically linear motors. You provide a DC voltage and the motor drives out 20 mil, and you reverse it and it drives back in 20 mil. And they had this little chestnut board, and they sold them on their store at the time. It's now closed, as I said. But you can never get them because they basically bought a batch in and used them for their own internal use. And if they had a few spare, they'd sell them to the community. And I waited many months to try and get one, couldn't get one. So because, like I say, I do a lot of IoT stuff, I use a lot of Adafruit boards manufactured in New York. So I basically bought an Adafruit Feather M0. And the Feather boards are they're basically matchbox sized boards. And they cost, I think the one I use is like $28 or £28, sorry. And that's got Bluetooth on it. It's got an M0 AVR microcontroller, SAM-ND microcontroller board on board, and enough I/O pins to control all the motors and the lights, the LEDs, that sort of thing, all built in. For £28. The chestnut board from Open Bionics was £250 plus postage, packing, and a bit of VAT. So I'd already dropped the price considerably. It then meant I needed to heavily rewrite the code that they provided that loaded onto the chestnut board. They gave that code base the name of Beetroot. I'm not sure where their naming conventions come from. You got Brunel, Chestnut, and Beetroot. But hey, they must have a reason.
I could understand Ada and I could understand Brunel.
Yeah.
But yeah,
Chestnut,
not Chestnut and Beetroot. No.
Yeah. So I took the Beetroot software, the code base that they had, which is all written in Arduino C. And if anyone's ever worked with Arduino C, you'll know how painful it is. It's basically a version of C that's been heavily adapted. So chuck away standard in, standard out, because you haven't got a keyboard and a screen anyway. But now you've got general purpose input output, so GPIO pins, PWM signals for pulse width modulation, all these kind of extra bits that are bolted into the microcontroller. So I took the codes, heavily modified it so it would work on the Adafruit boards, plugged in the motors that I bought off the internet, and had them working. It took a couple of months, backs and forwards, and trying to get it working, but eventually got it all working. So now my electronics are an Adafruit controller board, a motor controller board from Adafruit as well, which is £18. So for less than £50, I've got the controller working exactly the same as the chestnut board. But the difference is that the chestnut board was single source supplier, and you now can't get it anymore. So if I had gone down that route and Caden had broken the board bar, dropping it in a swimming pool, for example, then we'd be stuffed. Whereas these Adafruit boards, you mentioned we met at NDC London last year. 2 days before NDC London, I was working on the boards, and I plugged the battery in as well as having USB power from my USB power brick. And at the time, I hadn't modified the board to say that don't power from both sources, and it did, and I ended up making a smoke generator.
Nice.
So 2 days before I'm giving a conference talk in London to a bunch of people, I've blown up my board. But the Adafruit boards, you can literally go on Amazon, and that's what I did that evening. Went on Amazon and ordered the boards, and the next morning the postman was knocking on my door and handing me the boards. I quickly soldered the circuit back together again to cut the valves to do the soldering, and I was good to go again. So
Yeah.
another advantage of using these cheap boards is the fact that you can buy them. I mean, you can get them off eBay, you can get them anywhere in the world. There's cheap knockoff versions that come from China as well, which a third of the price. But you take your risk with, is it going to work, and is it going to continue to work? So yeah, I've got the price point down on the board as well, and as I say, using the Arduino C. The good thing about using Arduino C, or say the bad, take that back. The bad thing about using Arduino C is the Arduino IDE. I'm not sure if you've
Yeah.
ever fired up the Arduino IDE, but it's basically Notepad with a couple of extra buttons. It's not very good.
Nice.
Anyone who uses it will know it's pretty poor, and it's not really. It's kind of meant for the hobbyist. It's not really an IDE in my mind. It's only a couple of buttons. It doesn't really do too much. You can use VS Code, which is
Yep.
we all know and love, is a brilliant, starts fast. It's a fantastic IDE, but the Arduino plugin for VS Code effectively just uses, you need to have the Arduino IDE installed, and VS Code just calls into that IDE under the hood, which is great because you then got VS Code and it works better, but it's still using the Arduino IDE, which is fine. It does the job. But if you're doing development, you want to be able to have breakpoints. You can't do that with hardware. You can't
Yeah.
kind of stop the processor mid flow and say, well, what's the value of that kind of variable there? You can blink a light or an LED, or you can get it to send a serial signal back to your PC and watch it on a serial port monitor. But that's about all you can do. Whereas if you go and use Visual Studio, which we all know and love, even the community edition, you can add a completely free tool called Visual Micro, which is completely free. There's a paid version, and that basically gets rid of a couple of adverts when it opens. And I highly recommend it. It's worth paying. I think it's £40 or something like that. And that basically gives you Arduino C capabilities within Visual Studio with full-blown Visual Studio. You've got your full IDE with all your normal key bindings that you're used to for doing all sorts of wonderful stuff. Relaying out the code and taking it out into a new model, that sort of thing. Whatever it is you want to do within Visual Studio, all exists because it is Visual Studio. But it gives you, Visual Micro allows you to download the code to the Arduino boards. But it also gives you F9 debugging again, which is fantastic. And the way he cheats at doing that is when you build your code and push it to the board, he puts a do while loop where you've put the F9, puts a little do while loop, the next
Yeah.
instruction after the one you put the F9, and then it sits there waiting for you to click F5 again or F11 to step on.
Sure.
And it will then go to the next. So F11 will take you to the next breakpoint. It won't take you to the next line of code. So it's subtly different, but it's good enough that you can stop the code. Yeah, get your voltmeter out,
Yep.
and see what's going on with the hardware. You can hover over, and it will get you the variables on that line of code, and you can view those variables. Which means you then back to how you develop any .NET Core application, any Xamarin application. You're back to being a developer and doing what you know and love, and your normal workflows all work, and you're within Visual Studio. So your coordination that you use within Visual Studio is all still there for the key bindings and what you do. So I use that and say built the codes, edited it heavily for to work on the new boards, and yeah, that's what I'm using now.
Cool. So you mentioned Xamarin there, and I think I've seen mention elsewhere online that you use Xamarin, but how does Xamarin sort of fall into this project?
Well, the going back to Open Bionics, if you get one of their arms, the earlier ones or even the later ones, if you need to make a change, you need to go and see the Open Bionics team or see your prosthetic surgeon, and they make the change for you. So things like the gain levels on the muscle sensors,
Yep.
maybe the grips that you have loaded, you want to change them. They need to plug the board that's in the back of the hand into a computer. Developer taps away at the keyboard, does some setting changes, changes some of the gain levels, changes some of the timers that are used inside the code. Rebuilds it, recompiles it, stuffs it, downloads it to hand again. You check it, make sure you're happy. Yep, I'm happy, and off you go again. A few months later, you want to make a change again. You go back to your prosthetic surgeon. That wouldn't work if we're sticking, all this kit in a box and sending it to some part of the world that, there isn't a developer nearby that has a laptop that can run the Arduino IDE, that sort of thing. So it then become obvious that, well, if all we're doing is changing the settings every now and again, or actually Caden wants to make his own grip because he wants to play his Xbox, why do we need to edit the code? Why can't we do this in an app and send it to the board, and the board sticks it into the memory, and then when it boots, it says, "Oh, I've got these extra grips that are on top of the standard pack. I'll use those as well." And the timer setting for the hold time is this, not what was originally loaded. So because I do a lot of Xamarin development and mobile development, I basically made a mobile app. Again, it's on my GitHub. You can download it and take a look and submit PRs, that sort of thing. I've made a Xamarin app that allows Caden to change the settings of his hands, allows him to build his own grips using the grip builder. So he's made a grip which works for his Xbox. So he can hold his Xbox and use his fingers of his other hand to move the controls around, which he couldn't do before. So now he can play his Xbox with his friends, which is,
Nice.
fantastic.
Mm.
And it's all written in Xamarin. The reason I've used Xamarin is because I'm a Android person. Caden's an iOS person. He's got his iPhone. I've got my Android phone, and I didn't want to write in Android and again in iOS. So, Xamarin's cross-platform, works everywhere. Also, I wanted it to be cross-platform, but I also needed access to the Bluetooth stack so that I can connect the phone to the board. I needed access to things like accessibility because Caden's missing an arm. His other hand, he doesn't have his middle two fingers, so he's literally got his thumb and his pinky. His middle fingers are not there, so
Okay.
he needs to use accessibility settings of his iPhone to control it. So on his phone, the buttons are slightly bigger so that he can hit them with his fingers because he's less accurate than you and I would be. He can't scroll as easy because he can't hold the phone and use his thumbs. You just flick the screen up and scroll the screen. So things like that you or I don't really consider as being an issue. For Caden, they are. So
Yeah.
the good thing about Xamarin is the fact that it uses accessibility and it just builds on top of it. So I don't need to think about it in my app. Some bits I do, like button sizes and stuff like that. I make them slightly bigger, but because Caden then has his settings set to make that button bigger and change this, I don't need to think about it. The accessibility that Apple have developed or Google have developed for the Android is just done for me.
Yep.
That's and again also it's C#.net. So and that's what I know and love. So it just works.
Yeah, that's fantastic. It is fantastic. And the fact that a lot of these things are already done for us makes it so much better. I always refer to .NET as pretend programming because we're standing on the shoulders of giants.
Yes, we are.
But it's made this whole process so much better.
Yeah. And the good thing
So
as well is Xamarin's open source, just like .NET.
yeah,
There was a problem with there's a bug in the stepper control that was using Xamarin, and because it's open source, I went in there and I could see the bug. And it was like, actually, I can see how to fix that. So I did a PR and fixed it. It's now in the stable release of the Xamarin. And all it was if you use a value that was less than 1, so 0.25, for example, as I was using, as you stepped away from 0 and stepped back, because it was a double underneath, it stepped back and it kept the exponent. So you ended up with 0 point and then an exponent figure because it never actually went back to 0.
sure.
So it just needed that bug fixing. So I fixed the bug, submitted a PR. It got pulled in a few months back, and it's now part of the code base. It's kind of cool
Nice.
having Microsoft using your code and anyone that uses Xamarin using your code. But it means that you can do that. If you find something wrong, go and fix it.
Yeah. Yeah, and that open source side of the .NET framework and that is so much better. Um, I remember that with the Ajax toolkit many years ago, that there was an issue with I think it was with the calendar, and it wasn't going to get fixed anytime soon because release cadence was so slow back then with .NET that we would have been waiting months or years to fix it. We had to decompile the library, fix the bug, and then recompile it.
Yeah,
Whereas now you would have gone, checked it out, changed the code, and then built it, and it all would have been fine. You could have PR'd it in, and it would have gone in a lot quicker.
yeah.
So yeah, stuff like that is awesome. Is
Yeah.
absolutely awesome though.
Yeah, I mean that's literally what I did. Is I pulled the codes, made the edit, got it working locally, used it in my project, done the PR. Took a couple months for the PR to get accepted and pulled in. But now I don't need to use my local edit. Now I just use the stable version because
Yeah,
it's already in there. It's just like you say, it's cool to be able to do that.
yeah. So jumping back to something you mentioned earlier about the original arms that would have been used is that the hook had it could open and close or however it moved by the wearer moving their opposite shoulder.
Yep.
Now I'm going to use probably the completely wrong terms, but I've seen other projects where they've used like electrical impulse detectors glued onto the skin of the wearer to make the hand move,
Yep.
to detect the muscles and things like that. Is that how you do yours? How does yours work?
Um,
Or is that a trade secret?
No, 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 no. Nothing in this project is secret. It's all on GitHub. I encourage anyone to go and download it and play. The original designs that, again, back to OpenBionics and how they designed it originally, used these MyAware sensors that are basically, like you say, they basically, if you have an ECG, you have those little sticky tabs stuck all over your chest,
Yep.
don't you? It basically works like an ECG. It measures the muscle using the EMG signals. But you needed two of those, and they were £35 each, so it's £70, and it's a bit of electronics that you know a child is going to break.
Yep.
No buts or maybes, they will. They're children. That's what they do. Um, and those each board needed three sticky tabs, um, just like you have with an ECG. Now the sticky tabs you can get a bag of 50 for £5, so not expensive, but a bag of 50 when you need 6 of them per day, it's going to last you about 8 days. So every kind of week, effectively, you're going to spend £5 to buy new sticky tabs,
Yep.
which is fine early on. We went with it; it worked, but they weren't. I kept coming back to I want to make this cheap and easy to use, no matter where you are in the world. So it was okay, but they didn't like it. So um, I see Hackerspace is a magazine I read. It's all about IoT, electronics, and making things. Brilliant magazine. I see in there was an article. I literally flown along reading the article, and it's about Arduino debugging. And I was like, oh, what recommendations have they got for Arduino debugging? And they had a little sensor plugged into a prototyping board, and they were debugging, the readings from the sensor. I was more interested in the sensor because basically what they were doing was hitting the sensor to create a value, a sense value, and that sensor was a piezoelectric sensor. So just like your PC has got a little buzzer on the motherboard, that's a
Yep.
piezoelectric buzzer. So you apply a voltage to
Mm-hmm.
it, it makes a sound. Yeah,
Yep.
four buzzes for I don't know, is it GPU's broken or something, or memory's broken? I can't remember now.
Yeah. Yeah.
Google it, Stack Overflow. And so I bought a bunch of these sensors. I literally landed, went straight on my phone, and a pack of 10 from Amazon was £1 delivered to my door. I'm not sure how Amazon make a profit on that. I'd love to know how they can send a pack of anything to my door for less than £1, but there you go. So I got home from my trip and plugged it into the board, edited the code because the way a piezoelectric sensor works is you apply a pressure to it, or bash it basically, and it gives out a micro voltage which you can then register using the analog input of the Arduino board.
Mm-hmm.
So I plugged it in. It's great. It's fantastic. That works. I can actuate the arm, open and close it. This is brilliant. Let's go give it to Caden. Gave it to Caden, and Caden kind of played with it for literally 2 or 3 minutes. and then said, I can't stop in the middle now. I was like, what? He said, well, with the old ones, I could kind of move the hands and then kind of stop applying a force on the sensor, and the hand stops. Now, if I twitch my muscle, it now completely closes or completely opens. And it hadn't occurred to me until that point that I actually had not fine motor control, but a version of motor control before. Whereas
Yeah.
now, all I was doing, because once you hit the sensor, it gives your voltage out, but until you hit it again, you're not going to get any more voltage. So all I was doing was, I'd literally comment out a bunch of code and said, if I see a value from the sensor, open it or close it, do the opposite of where it is at the moment. Which seems simple enough, but usability testing proved it was wrong. So I walked away, tail between my legs, thought to myself, well, okay, we'll try something different. And then I was searching around for sensors, because now I thought to myself, well, I need to fix this problem. And then I found force sensing resistors, FSRs, on a website called SparkFun. Did a bit of research on those. Again, you can buy them from Amazon. So I bought a couple from Amazon. They're £6 each. Needed two. It's not quite £30 each, but these literally are just little thin film plastic things that no kid's going to be able to break. And the more pressure you apply, the more voltage they let out. So they're literally a variable resistor. So I wired that in, and actually it works a lot better than the MyAware electronics that we were originally using. And they're £6 each, and he can't break them. He doesn't need to put sticky pads on. It doesn't stick to his skin.
Yeah.
Literally, the socket that goes onto his stump is hard plastic, and when he tenses his muscle, it squashes the sensor between his skin and the hard plastic socket, and gives me a voltage out. And it's as simple as that.
Yeah.
So
Yeah, that's awesome, because you got away from a couple of different issues as well. Because you were saying about sending them out around the world, and I know that my mum suffers with issues with the glue that they use on plasters, that she's allergic to it. Now, certain glues on certain plasters don't stick to my skin, even though it sounds a bit odd.
yeah,
Like the waterproof plasters, I know loads of people that use them and they're fine. They don't stick to me at all. Maybe I'm too greasy or something, I don't know. But not having to have a sensor that's got to be glued on in some way gets away from any of those irritations. You cut the cost down again.
yeah,
Is it the art of no, something about necessity breeds art or something like that. I can't remember the right term now, but the need has been met
yeah,
by you finding the better alternative.
yeah. And they work really, really well. And as I say, they're much cheaper and much simpler design, and it means there's less work to solder them into the circuit as well. So it's easier to build the electronics as well. So not only are they cheaper, better to use, but it means that the person building the electronics has got less solder connections to make. It solves so many problems within the project just by changing this one sensor that is super simple to use.
Yeah,
Yeah. So, and just so you're aware, I mean, these sensors you squash, like I say, you squash your muscle. But if you was to put take your fingers and hold your arm up, if you put your fingers either side, I'm trying to. I know this is a podcast, so it's difficult to describe. If you bend your arm up like you're doing the kind of I'm tensing your muscles, I'm super strong like Popeye. If you take
yeah,
your fingers and put them either side of your forearm,
yeah.
just above your elbow. Yeah.
Hmm.
If you move your hand so it points away from you, you'll feel the muscle at the back of your arm tense. If you move
Yeah,
your hand so it points towards you, yeah,
yeah,
the muscle at the front will tense. And if you make a fist, both muscles tense. And
yeah,
that's what we sense. So we have two sensors. One senses the hand pointing away, which we call open, because the palm is open. The other one is the palm closed, pointing towards you. And you grip your fist, or Caden grips his fist, and that tenses both muscles. So we get a reading from both muscles. Then we change the next grip in the grip sequence. And that's how we give him the control that he can go through the grip sequence. He has to or until recently, he had to remember the sequence where he was in the grip sequence. But now we've added an LED to the side of the hand. So
yeah,
he, using the Xamarin app, he can control the color of that LED for which grip. So for him, the fist grip is a red, red for angry is the way he remembers it. And that literally makes the hand make a fist. And he sees red, he knows he's on the fist grip. He knows the next grip in the sequence, is the palm grip,
Hmm.
which is where it's literally where you've just got your fingers bent as if you're holding a carrier bag. Yeah, for him
Yeah,
that's green. Yeah, so he can see if it's red, the next one's going to be green because he remembers that, and he can see, oh, it's gone green. That's the palm grip, and he can go through the grip sequence. Using the Xamarin app, he can also reorder those grips, so he can move the palm grip, which is green, in front of the red fist grip. And he does that every now and again for different things he's doing. Like at school, he has a different grip sequence than what you would have at home, for example, because he doesn't need his Xbox grip when he's at school. So he deletes
sure.
that out of his grip sequences, so that he now only has 2 or 3 grips at school and 2 or 3 grips at home. And these are
Yep.
things that we're still playing with and trying to work out the best way of having an app put this together. But that's how we've
Yeah,
got
yeah,
it working at the moment. And yeah, but that's, the sensors are super cheap, super simple, and the chances they stick inside the plastic sockets. They're made by 3M, so they've got like a really good glue on the back of them,
yeah, yeah.
and they just stick inside, and you never need to touch them again.
Yeah, I guess you could use something like if this then that for GPS location. So as he gets into school, it sends a call out, updates his grip, so he doesn't even have to change it himself and stuff like that. That'd be pretty cool.
Yeah, that was I gave the talk at NDC back in January, and that was an idea that came from the audience. There was much the same, using the phone's GPS and saying, "Oh, well, actually, I noticed you in the school," and just geofencing it. I noticed you in the school grounds, therefore I've changed your grip sequence for you.
Yeah, yeah,
Another thing that I did a talk at Knott's AOT meetup last week, and someone sitting listening to the talk there suggested that I use a smartwatch, so like a Samsung Galaxy Watch, and allow him to change the grip sequences on the smartwatch. So you can wear the smartwatch, and it'll, rather than getting the phone out of the pocket to decide which grip pack he's using, or change a setting, he can just do it on the smartwatch. So
yeah,
I walked away from that with, oh, now I've got to buy a smartwatch. I mean,
yeah. Yeah, that you're slowly pushing that price bracket back up again.
Well, I am, yeah, but I get to play with a smartwatch and a bit more Xamarin tech. So, because again,
Yeah,
Xamarin, I can target the smartwatch as well as I can target a mobile app. So, my code base stays the same as a couple of UI changes, but there's not much else.
sure.
It's again, it's come back to using the .NET platforms, and being able to target what I need to target.
Yeah, yeah, cool. So we've talked about the arm. Are there any other limbs that you may be working on? I don't know, like a prosthetic tail or something like that, a prehensile tail.
Yeah, no, it's funny you say that. Macaulay, my eldest son, he turns 24 soon, so it's making me feel super old. Um, uh, my uncle's, his great uncle, had his right leg amputated for medical reasons, basically
Yeah,
diabetic and stuff like that,
sure.
about a year and a half ago. So, because Macaulay's been helping with all the 3D design of the arm, we often joke that next we'll make Uncle Paul a leg. And it is something that we're actually starting to seriously look at now. We're coming towards the end of the handy project, to a point where we've got it almost where we need it to be. A little bit more work on the Xamarin app to change some things, but otherwise the hardware and the 3D printing is pretty much solid and what we need now. So next we're going to start looking at 3D printing the leg and seeing what we can do with that, because he has a prosthetic leg from the NHS, but it's a pretty dumb kind of, again, it's back to mechanical. It's got some
Yep.
springs that flip the foot back in the right position. He finds it very difficult to walk on. He's a big guy. That's why he's diabetic, because that's his lifestyle. So yeah, so that's next on the to-do list from me and Macaulay, is to make a 3D printed prosthetic leg, and again put some motors and smarts inside. That means that it'll do what it needs to do, and help hopefully get Paul will be a test case, but hopefully again it'll be another thing we can box up and send around the world.
Yeah, yeah, that's amazing. So these are some hefty projects. You've already said that they're open source. If somebody wanted to get involved with your project, or if they wanted to start their own project, where would you tell them to go to get started?
Well, they're more than welcome. Everything I've done on the Handy project has become known on Twitter. Everything is on my GitHub. So if you go to Cliff Agius /Handy, you'll see 3 projects. There's one which is the 3D printing parts. Another one is the electronics in the back of the hand. So the electronic circuit diagram, and also the software that loads onto the 80-foot boards. And then the third one is the Handy app, which is the Xamarin application, that talks Bluetooth to the hand, but also talks out to Azure Functions. It sends up the muscle readings that it takes during the day. And at some point in the future, at the moment I'm just storing it in table storage. At some point in the future, when I've kind of got a bit of time and found someone that's better at ML than I am, the idea is that we get ML to run over those muscle reading sensors, muscle reading values, and decide what the sensor value should be within the arm. So it will run over them, send the value back to the Xamarin app, which then, when it next connects to the arm, can update the values in the settings. That being, Caden doesn't need to manually go in and change the settings every few weeks. Because it's a muscle at the end of the day. He uses the muscle, that muscle's getting stronger and stronger, and just like muscles do, that's what they do. Which means the muscle readings will overread as the muscle gets stronger. So we need to dial back the gain levels as he uses it. But if we can get ML to decide what that is, I'm told by people that know this stuff that the machine learning, it's 2 values that go up and down. It's a fairly simple model to reason over that data. They're far smarter than I am, so I'm letting them worry about that, and they can design the model. But yeah, at the moment that's what we're doing. The other thing I'm tracking as well, using Azure Function, is which grips he's using, which are his favorite grips. And also, again, an idea that came from NDC was to track which grips he uses in which location. Obviously, Caden's given permission for his location to be tracked as well. The idea being is we can build up those grip packs based on the geofencing. So we know he was roughly in that area, which is school. Therefore, the grips he's using at school are these ones. So therefore, instead of having 5 grips, you only ever use 2 of them. So let's just make it simple. You have 2 grips. And again, that is something that machine learning done in the cloud. I dare say you could probably do it, and Xamarin can run a machine learning model as well once it's been trained. So once it's been trained in the cloud, there's no reason why it can't just be on device. But yeah, as I know nothing about machine learning. It wouldn't be for me to do, but I'll find some smart person to do it for me.
Sure. And you're selling yourself a little bit short there, because as someone that takes stuff out of a database and does things to it and puts it back into a database or sends it somewhere else, the conversation that we've had this evening for this episode, it's blown my mind. I wouldn't say a little. I would say a lot. I'm astounded at what you've achieved. It's an amazing project. And I would never have thought to even start looking at something like this. So, firstly,
I didn't plan to start this project. I was asked in the school playground, December 2016, can you help? And it's grown from that. Like all development, we all start out kind of learning something. If you've got a pet project that you start working on, you probably don't know much about it. I mean, before we started this podcast, you talked about a pet project where you learning some new things that you hadn't used before. That's how you learn. Is you have these pet projects that you start doing. I've learned so much. I've learned a bit on my engineering background for the robotics and the electronics, but all the coding software I've had to learn, because it's stuff that a client's never going to come to me and say, "I need you to build an app to do this." I've had to work through the problems, and work through them, think up solutions. Sometimes they work, sometimes they don't, and you just move on. Break it down into small chunks, and I broke it down into 3 chunks of, the material and the 3D printing is one area, the electronics in the hands is another area, and the Xamarin app and the cloud is another area, and that's how I've broken it down. And I kind of pick up one of the three arms of the project. No pun intended. One of the three arms of the project, and work on them as if I'm stuck on that bit, I work on that bit, and like I say, we're now starting to look at legs. It's just taking what we've already done and worked on and just adapting it for a different limb. And the idea is that it won't cost you an arm and a leg when we're done.
Boom.
Yeah. But if anyone's out there listening to this, it's all on GitHub. Come and join in. If you see something I'm doing wrong, I'm a developer just like you. I make mistakes just like anyone else. We're all human. We're all fallible. I'm not ashamed of being wrong. Just come and jump in, point out where I'm wrong. Jump in, help in the project. If you know a bit about machine learning and want to jump in and help, reach out, Twitter, GitHub, and help out as you can. Hopefully this project will kind of move on to something that can be boxed up and sent around the world.
Yeah, definitely. And we'll include all those links and all the things that we've talked about in the show notes. But that leaves me with saying thank you, Cliff, for coming on and talking to us.
It's been an absolute pleasure. It's been great to talk again. It's been a long time since we last spoken, but yeah, it's been good to talk.
Yeah, definitely. And thank you to everybody out there for listening. I'm James Stoddart, and you've been listening to Clifford Agius talking about piloting .NET Prosthetics. If you have any questions about this or any other episode, then drop us an email, a tweet, or leave a comment on the website where you can find all the resource links, show notes for each episode. And if you enjoy this episode, please leave a review on your favourite podcast platform, iTunes, Stitcher, whatever it is, and help the Cynical Developer to reach more developers around the globe.